Backyard Brains presents the electrocardiogram, also known as the EKG or ECG. For this experiment, you need a heart and brain spiker shield, an Arduino, a computer, and yourself. The heart contains specialized cells called pacemakers that spontaneously discharge in rhythmic patterns to control the contractions of various parts of the heart. We can record the electrical activity of these contractions of the heart by placing electrodes in various configurations across the human body. In the first configuration, Florencia will place one electrode on Pablo's inner right wrist, another electrode on his inner left wrist, and the ground electrode on the back of his left hand. This will allow us to measure the potential difference across his chest. With our orange interface cable, we will connect each red alligator clip to each inner wrist and the black alligator clip to the back of the hand. We then plug the orange cable into the orange port on the heart and brain spiker shield and the USB cable on the other side. The other end of the USB cable goes into the computer, and we are ready to begin. Open our Spike Recorder software, and in the config settings, unmute the speakers and connect via USB port. Within 1 to 2 seconds, you will see the iconic impulses of heart contraction. The plus and minus signs on the left side of the screen can increase or decrease the size of the visualization, and you can also click on the threshold button to enter threshold mode, which centers the impulse to allow you to examine it more closely. Clicking on the heart button on the top of the screen will show you the heart rate and interbeat interval, and also beeps. You can also take a signal average, which is very useful in noisy environments when you want to see the P wave, QRS, and T wave components of the electrocardiogram signal. But let's do an experiment. The medulla oblongata in your brain influences your heart rate. For example, when you are exercising, your body has higher oxygen needs. The medulla tells the heart to beat faster to provide more oxygen to various parts of your body. We can test this by having Pablo go for a jog, and then we'll hook up the electrodes to see the effect of the exercise on his heart rate. As expected, his heart rate has increased from a baseline of 70 to 80 beats per minute to 120 to 130 beats per minute. As Pablo then relaxes, his medulla oblongata tells his heart to return to its baseline rate. If you are finding isolation of your EKG signal difficult, you can use an alternative configuration where you place the red electrodes above and below your heart on your left chest and the black ground electrode on your upper right chest. This will result in a much higher signal-to-noise ratio signal. Note that sometimes your EKG signal will look a little peculiar. What is going on here? Why, the signal is upside down. But have no fear, simply swap the position of the two red alligator clips, and your EKG should then look normal again. We thank our production team, and this is only just the beginning. Perhaps we can build some sort of interface where we connect the heart rate to an instrument. Stay tuned. Backyard Brains, neuroscience for everyone.